This is video 3 of the Solving Rational Equations Easy Worksheet on the KutaSoftware website. In this video, we're doing numbers 11 through 15. And remember, there's multiple ways to reach each solution, so feel free to do it a different way. In number 11, I'm going to start by rearranging the equation. I have two denominators that are the same, but I need them on the same side in order to combine. So I'm going to start by subtracting 1 over b squared minus 7b plus 10. I'll have 1 over b minus 2 on the left-hand side, and that will be equal to 2 minus 1 over b squared minus 7b plus 10, since I can combine the numerators on the right. So 2 minus 1 over b squared minus 7b plus 10. So I'll have 1 over b minus 2 on the left, and then 2 minus 1 all over b squared minus 7b plus 10 is the same as 1, since 2 minus 1 is 1, over b squared minus 7b plus 10. However, instead of writing b squared minus 7b plus 10, I'm going to split it up and write it as b minus 2 times b minus 5. Now you may be a little confused at how I can change b squared minus 7b plus 10 into b minus 2 times b minus 5. But think about foiling this. So first, outside, inside, and then last. That's how you're going to multiply each of the terms. B times b is b squared. Negative 2 times b is negative 2b, but you're going to add that to negative 5 times b to get that negative 7b. And then negative 2 times negative 5 is a positive 10. So we have b squared plus negative 7b, or minus 7b, plus 10. An easier way to think about that is that the 2 and the 5 have to add to equal 7 and multiply to equal 10. So negative 2 plus negative 5 equals 7, and negative 2 times negative 5 equals a positive 10. So now that I've rewritten that, I can multiply both sides by b minus 2 over b minus 5. When I do that, the b minus 2 times b minus 5 on the right-hand side cancels out, and the b minus 2 on the left-hand side cancels out. b minus 5 times 1 is b minus 5. Then all I have to do is add 5 to both sides. That will leave me with b equal to 6. And that's the solution in number 11. Let's move on to number 12. In number 12, again, I'm going to rearrange so that we can combine similar fractions. So I'm going to start by subtracting 1 over x squared minus 3x from both sides. Doing that will leave me with 1 over x minus 3 on the left-hand side, and that's equal to 3 minus 1 all over x squared minus 3x. We have 1 over x minus 3 on the left, and that's equal to 3 minus 1, which is 2, all over x squared minus 3x. We can simplify that by pulling an x out. So we'll have x times x minus 3. Since x times x is x squared, and x times negative 3 is negative 3x. So x times x minus 3 is equivalent to x squared minus 3x. Now, we'll be able to multiply both sides by x times x minus 3. Doing that will leave us with the positive 2 on the right-hand side, and the x minus 3's will cancel out, so we'll be left with x times 1, which is x. So x equals 2 is the solution for number 12. In number 13, we're going to have to make a common denominator. Remember, multiplying any quantity by 1 will not change the value. So if I multiply 1 over p minus 5 by p over p, which is that 1, since p over p is equal to 1, I'll have 6 over p, and that's equal to p all over p times p minus 5. Then we're going to subtract p plus 4 all over p squared minus 5p. And notice that now we have a common denominator, because if we were to distribute this p, we would get p squared minus 5p. So we can combine these numerators now. We'll have 6 over p, so p minus p plus 4 is p minus p, and then we're subtracting that 4 since this negative, or the subtraction, would be distributed. So we'll have negative 4 all over p times p minus 5. And that's because, if you need to write this down, that p squared minus 5p is equal to p times p minus 5. They are equivalent. But you can see that now all I have to do is multiply by p times p minus 5 to cancel that out on the left-hand side. And when I do the same to the right, p times p minus 5, I cancel out the p in the denominator on the left. So I'll have 6 times p minus 5, and that's equal to negative 4. My next step will be to distribute that 6. So 6 times p is 6p, minus 6 times 5 is 30, and that's equal to negative 4. Adding 30 to both sides will give me that 6p is equal to positive 26. Then I'll divide both sides by 6 to get that p is equal to 26 over 6. But we can simplify this down. If we divide both by 2, so 26 divided by 2 is 13, and 6 divided by 2 is 3. So p equals 13/3 is the solution for number 13. In number 14, again, I'm going to start by rearranging this equation. I'm going to subtract a 5x minus 20 all over x squared minus 9x plus 18 from both sides. So when I subtract it from this side, it'll cancel out with this positive, and then I'll subtract it from the right. I'll be left with 1 over x minus 6 on the left-hand side, and that's equal to x minus 4 minus 5x minus 20 all over x squared minus 9x plus 18. So x minus 4 minus 5x minus 20. So 1 over x minus 6, and then I'm going to distribute that negative. So x minus 5x is going to be negative 4x, and negative 4 minus a negative 20 is going to be negative 4 plus 20, which will be a positive 16. So negative 4x plus 16 all over x squared minus 9x plus 18. But let's look at this x squared minus 9x plus 18. I want to rewrite that as x plus or minus some quantity times x plus or minus some quantity. So we need to see what two numbers add to give us a negative 9 and multiply to give us an 18. So let's think about the factors of 18. We have 2 and 9, but there's no combination that would create a negative 9 out of that. We also have a 3 and 6, which, if we take negative 3 and add it to negative 6, we'll get that negative 9, and a negative 3 times a negative 6 is a positive 18. So the numbers we're looking for are x minus 6 and x minus 3. That would give us x squared minus 9x plus 18. So I'm going to rewrite x squared minus 9x plus 18 as x minus 6 times x minus 3. So rewriting that in the denominator, x minus 6 times x minus 3. Now I'm going to multiply both sides by x minus 6 times x minus 3. You'll see that on the right-hand side, that denominator will be canceled out. So I'll have negative 4x plus 16, and that's going to be equal to, on the left-hand side, x minus 6 cancels out. And we have 1 times x minus 3, which is x minus 3. Now I'm going to combine like terms. I'm going to add a 3 to both sides to get that x equals negative 4x plus 19. And then I'm going to add a 4x to both sides to get that 5x equals 19. Dividing both sides by 5, we'll isolate that x, and I'll have x equal to 19 fifths. So 19 fifths is the solution for number 14. Moving on to number 15, I'm going to start this one by multiplying 6 over 5k plus 2 by a 1. And that 1 is going to be k over k. Doing this, I'll have 1 over 5k squared plus 2k minus 6k over 5k squared plus 2k, and that's equal to 6 over 5k squared plus 2k. So combining these fractions, I'll have 1 minus 6k all over 5k squared plus 2k, and that's going to be equal to 6 over 5k squared plus 2k. I'm going to multiply both sides by 5k squared plus 2k, which is the same as multiplying by 5k plus 2 times k. So 5k squared plus 2k. On both sides, the denominator will be canceled out, and we'll have 1 minus 6k equal 6. Subtract 1 from both sides to get that negative 6k equals a positive 5. Then we'll divide both sides by that negative 6 to get that k equals 5 over negative 6, so negative 5/6. So negative 5/6 is the answer for number 15. And that wraps up the third video. Please join me in the next video where I'll do numbers 16 through 20, finishing out the worksheet. Also, please remember that all likes and subscriptions are greatly appreciated, so go ahead and do that now.